Good evening, good evening. We are live again with another night of math on Monday night. So welcome one, welcome all. Started a little late, but hey, we are here. Uh-oh. All right. Had some troubles, but I'm here tonight. I'm here. Okay, so let's get started. So tonight, if you need some help, just give me a text at 407-801-9255. I'm here and I am available. So tonight we're going to focus on 8th grade math again. If no one texts me, this is what I'll be doing. Okie doke. Okay. So let's look at this first problem. It says, how many solutions does the equation shown have? So in order to find the solutions, we actually have to solve for x. So let's go ahead and let's get started. So let's solve for x. First thing we got to do. Sometimes you could clear the fractions, because some people don't like working with fractions, but I'm not scared of a fraction or two, so I'm going to go ahead and keep it. So I'm going to distribute the fraction to 1/4. So I'm going to put 1/4 x minus 3/4. Set that equal to, and I know that these are like terms here. So I'm going to go ahead and change this to where we have the same denominators, because at some point I got to combine them. So we're going to put a 4 here, put the x here, and we got to multiply that 3 by 4, so that's going to make that a 12 minus 11 over 4x minus 3. So on this left-hand side, we keep the 1/4 x minus the 3/4. And then we're going to combine these two terms here. And that's going to be actually 1/4 x minus 3. Now we're going to subtract 1/4 x from both sides of the equation. Let's get rid of it. We have made a zero pair on both sides. And so now we're left with negative 3/4 x. Well, negative 3/4 is equal to negative 3. This is not a true statement. So this is not true. They do not equal one another. So they say, how many solutions does this equation have? You can say no solutions. And that would be your answer. Okay, let's keep it moving. This question here, this question is intimidating because look at all those variables. I mean, it just has one number that we can see. But they got all these letters, X, an A, and a B. But it's really not that difficult. So it says, what values of A and B would make the equation shown have infinitely many solutions? In an equation, to have infinitely many solutions, you need to have where both sides equal each other. Like, for instance, x needs to equal x. So we need to make that scenario happen here. So what values of A and B would make this an infinitely many solutions? So let's just say we want to make the left-hand side 3x, but we also want to make the right-hand side 3x. So how would we get that to happen? Well, I know if I make my A equal to 3, and let's make the B equal to 0, I can make that happen. So if we say 3x is equal, instead of putting the A, we'll put 3x. Instead of putting B, we'll put 0, and there it is. 3x is equal to 3x. So that makes it infinitely many. So I'm going to say that the solution, the values of A and B, would need to be 3 and 0. If I'm wrong, correct me later. Show me another way. Alright, let's do this problem here. It says solve the equation shown for x. So you have 2 times x minus 4 is equal to 4x plus 3x plus 6. So we need to solve for x. So the first thing I'm going to do is distribute. So we have 2x minus 8 is equal to, I can go ahead and combine like terms too. So this would be 7x plus 6. So to get to this line, I did distributive property. I distribute the 2. And I combine like terms. Okay, that's what I did to get to this line. Now to the next line, I'm going to, if I'm using proper vocabulary or the terms in math, next I'm going to do the subtraction property of equality by subtracting the 7x from both sides. These are all things that students should know. This would be negative 5x minus 8 is equal to 6. So to get to this line, I did the subtraction property of equality. Okay. Next, I'm going to do the addition property of equality by bringing over the 8 to the right-hand side. I made my 0 pair, so now I have negative 5x is equal to 14. So to get to this line, I did the addition property of equality. And then the last step is to solve for x, is to divide both sides by negative 5. I made this equal to 1, so x is equal to negative 14/5. To get to the answer, I did the division property of equality. Okay, they didn't ask for the steps, but I thought I'd just put them out there anyway. It's always good to know how you got to each line in your solution. Okay, let's go to the next question. So for this question here, it says explain why 3 times x plus 4 is equal to 3 times x minus 5 has no solution. It says choose the best response below. Before I go through the responses, I'm just going to work this out and see what happens. So if I distribute the 3 on the left hand side, I get 3x plus 12. And then I distribute the 3 on the right hand side, I get 3x minus 15. I'm going to subtract the 3x from both sides, again using the subtraction property of equality. I have 0 pairs on both sides. So now it is going to be, hey Martin, you missed this for real, Martin? I don't believe that. Negative 15, so it'll be 12 equal to negative 15. Okay, so this is not a true statement. So this is, of course, no solution. They're correct about that. So let's say it says choose the best response. So the coefficients of x are the same. Well, that was true here. They are the same. But the constants are different. The constants are different. So that actually checks out. I'm going to pick that. So here it says that the coefficients of x are different. They were not different. They were the same. So we know not to pick part B. And then part C says the coefficients of x are the same, yes. And the constants are the same. The constants were not the same. They're 12 and negative 15. And then this one says the coefficients are different, yeah. So answer choice A is our best answer choice. But I like to go through each one of the answer choices just to make sure I have the right one. Let's go to another question. So this question says a graph of a system of 2 equations is shown. Use the add point tool to plot the solutions of the system. So in Florida, there's a when the students take the FSA What did you say, Martin? Yes, I do. LL, coming to class and struggling. LL, then breaking it down. You breaking it down. I still go. You are a mess, Martin. That's one of my old students, my high school students, and he is doing wonderful in life right now, right, Martin? That's awesome. Okay, so this, I just need to find a solution of the system of equations. So where they cross is where the solution is. So I just put a dot where it is, and so that ordered pair would be, let's see, 1, 2, 3, 4, 5, 6. So it's going to be 6 and -2. So this is going to be the solution to this system of equations. We always like it when the system is already graphed for us. All we got to do is pick the equation, pick the order pair. That's the best and easiest way. Now, when you have to graph it yourself, that's a whole nother story. Okay, let's look at this question here. It says, analyze the system of the two equations shown. So you have y equals 3 times x plus 4, and then you also have y equals 3 times x minus 4. How many solutions does the system of equations have? Is it no solution, one solution, or infinitely many solutions? Well, in order to find that out, when you have this system here, and both of them say y equals, you can set these equal to each other. So when I set up the equation, I'm going to put 3 times x plus 4 is equal to 3 and then x minus 4. So to solve it, I'm going to distribute the 3 on both sides. So on the left hand side, I get 3x plus 12. On the right hand side, I get 3x minus 12. Again, I'm going to subtract the 3 from both sides. Well, I'm going to subtract it from the right hand side. I'm like bringing it over to the left hand side. But it just so happened when I bring it over, I get 0 pairs on both sides. So now I'm left with 12 equal to -12. They might have the same number, but those are different numbers. You either got $12 or you don't have $12. So this right here is not a true statement. So when it's not true, it's going to be no solution. And there we go. Okay, let's keep going. Now, if you need help with your math, you can text me at 407-801-9255. I am accepting questions right now. But in the meantime, I'm just going to do some math. I won't be on here long unless you have questions. Okay, so here's another one. It says, a system of 2 equations is shown. So you have y equals 5x plus 3, and then y equals 3x minus 1. So what we need to do is graph them both. So let's graph them in different colors. So I'm going to use blue for this equation here. So in order to graph this one, y equals 5x plus 3, you got to pull out 2 pieces of information. You're going to need your y-intercept, and that is going to be 3, or you can write it as the ordered pair 0, 3. Then you're also going to need your slope. The slope comes from, it's a coefficient of the x. So in this case, it's going to be 5, or you can write it as 5 over 1, which means to go up 5 and then to the right 1. So on my graph, I graph the y-intercept first. So I go to 0, 3, or 3 on the y-axis. Then I need to go up 5 spaces into the right 1. So 1, 2, 3, 4, 5 over 1. I can reverse the slope as well and go down 5 and into the left. So 1, 2, 3, 4, 5, and over 1. And I could keep counting. 1, 2, 3, 4, 5 over 1. Okay? Now I'm going to attempt to draw a straight line. Does this have? No, it doesn't. Let's draw a straight line as much as possible. See, look at that. Sure, I need a ruler. But it's all good. Okay, you get the idea. That's why I put the dots. Or the points in this case. Okay. Let's do another one. Let's do this one in yellow. So the next equation, y equals 3x minus 1. Let's write it out. So my y-intercept is going to be -1, or I can write it as 0, -1. And then my slope is going to be the coefficient of x, which is 3, or you can write this as 3 over 1, which means to go up 3 and then to the right 1. So I start at 0, -1, so I go here, and here's -1 on the y-axis, and then I'm going to go up 3 units, so 1, 2, 3, and then to the right 1. And again, with the slope is your rate of change. It's what's happening every time you go up and then over, or down and then over. But I could keep going, so I go 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. Now I also can reverse it. Reverse it means to count backwards. So I could go down 3 and then to the left 1. So I could go from starting right here from the y-intercept again, go down 3. So 1, 2, 3, to the right, to the left 1. And you can see you're still on the same line. And then do it again. 1, 2, 3, to the right 1. Ooh, you see how I'm over that blue dot? That's what you want, because that's where your solution is. So let's draw a line. Draw your line. And it's supposed to be straight, but I don't have a ruler. So anyway, the idea here is, where do these two graphs, what is going to be the number for x and the number for y that's going to make these two lines equal each other? And so we know that this is the answer here. So the answer is going to be this order pair right here. And so this is at, what is that, -2. And let's go down 1, 2, 3. Oh, -7. So that would be my solution, -2 and -7. Now, with system of equations, you can solve them by graphing, you can solve them by substitution, you can solve it by elimination. So let me show you how to solve this same equation if you didn't have the graph, if you just needed to actually just do substitution. So let's do substitution. Let's just add this. They didn't ask for this, but we're going to do it anyway, because this is the Mrs. Taylor's classroom. So we could do 5x plus 3 is equal to 3x minus 1. So I need to subtract 3x from both sides because I want my variable on the left-hand side. Got my 0 pair on the right, and here I have 2x plus 3 is equal to -1. Now I'm going to subtract 3 from both sides. Got my 0 pair on the left-hand side, and so now I have 2x is equal to -4. To solve for x, I need to divide both sides by 2. And so x is equal to -2. Oh, look at that. That's what we discovered. X was -2. We discovered that in the graph. Now I can plug my 2 into either one of the equations and it still should work. So let's actually do blue for the first equation. If I say y is equal to 5 times -2 plus 3, I get negative 10 plus 3. And so y is equal to negative 7. That's what we discovered. Because that's what we have here. Okay? But I also could plug it into the other equation. The 3x minus 1. So if I say y is equal to 3 times negative 2 minus 1, I get negative 6 minus 1, which is also negative 7. So I'm still doing good. So you can solve a system of equations by graphing it or by actually doing the method of substitution or elimination. Okay, whichever one you know or remember. Okay, let's go to another question. Ooh, now look at this question here. Let's just say it's an immediate turn off, because some folks be like, wait, look at all those words, first of all. And if you're a person who don't like to read, or you have challenges when you're trying to read and understand, this is going to immediately turn you off. But as a student, as someone who's taking a test or needs to pass a test, you have to learn how to build your stamina when it comes to long questions. Because sometimes they're long for no reason. They're not difficult, they're just long. So let's read it. What you said? Oh no, I was one of those people. That's right, Martin. That's why I had to help you out, honey. Okay, so Martin, if you was here, I'd have you read this question out loud. But you not. It's okay. Rada is trying to choose between two bike rental companies, Company A and Company B. Company A charges a $25 initial fee and an additional $5 for each hour rented. Company B charges an initial $18 fee and an additional $6 for each hour rented. The total cost to rent a bike from Company A can be represented by the equation y equals 5h plus 25, where h represents the number of hours rented and y represents the cost in dollars. The total cost to rent a bike from Company B can be represented by the equation y equals 6h plus 18, where h represents the number of hours rented and y represents the cost in dollars. For how many hours of rental is the amount charged by the two companies the same? What is the cost in dollars for renting the bike for this many hours? So we have two things we got to answer. First, we got to figure out, well, what is going to be the number of hours that we're renting, and then how much it costs to rent the bike. So actually, this is a real world question. I know some of y'all be like, I don't want to figure that out. That's why I go to the store and they figure it out for me. But if you on a budget, you better learn how to figure this out for yourself. So, because sometimes we like to compare and shop. This is what we do. We need to compare and shop. So, this is actually a real life system of equations. So if you notice, Company A, they charge $5 an hour and then $25 for the initial fee. And then Company B charges $6 an hour and $18 for the initial fee. You want to know when are their prices going to be the same for the number of hours. So we can set them equal to each other. So let's do it. So this would be 5h plus 25 is equal to 6h plus 18. So let's subtract 6h from both sides. I always like my variables on the left hand side. I get my zero pair here. I get negative h plus 25 is equal to 18. And then I'm going to subtract 25 from both sides. Alright. I get negative h is equal to, I believe that's negative 7. Yes, it is. Now, we're not solving for negative hours because it doesn't make any sense. So we're going to divide both sides by -1. And we get positive hours is going to be 7. So for how many hours of rental is the amount charged by the two companies the same? So the answer here is going to be 7. So 7 hours for that. So we got our first answer. Now they want to know, what is the cost in dollars of renting the bike for this many hours? In this case, for 7 hours. So we could plug it into either one of the equations, but we're going to do both. So let's do this first one here. We'll do it in green. So we'll say y equals 5 times 7 plus 25. And we get y is equal to 35 plus 25. And so y is equal to 60. In this case, $60. But we should get the same answer when we plug it into this equation. So we say y is equal to 6 times 7 plus 18. And we get 42 plus 18. And again, we get 60. Or $60. So what is going to be the cost of renting the bike for 7 hours? For both will be $60. And that's our answer. See, that wasn't so bad. Okay, let's do another question. This one here says a graph is shown. It says, how do you determine if the graph is a function or not? Well, first off, let's highlight the points. So the points on this graph are here. I'm doing them in yellow. Here, here, and here. Okay, so is this a function? I can tell you right now it is not a function. But how do I know? With functions, you look at everything, how many x values does each y value have? Or is that, I've got it backwards. The inputs are the red lines. So each input can have only one output. So this is my input line. Okay, this is my input. And so when I'm looking at this red line, I see that the -4 has one output. Okay, and that's it right there. Okay. Then I see that there's -2, so they're counting by twos. This -2 has one output, so we're good to go, following directions. But if you look at this 2 right here, it has 2 outputs, this one and this one, and that is a no-no. You can't have them in the same line. So is this a function? No, it is not a function. This is not a function. Because each input does not have one output. Okay, let's change this to real life. So most people know if you're in a relationship, it's just you and the other person. It's not you and the other person and another person and another person. Okay? So that's what this is what this is representing. If you are you got a significant other, it's just you and that person, you and that person. But when you got you, it's you and that person, that ain't happening. So that's not functioning. That's not gonna function for most people. So that's how you can think of functions for math, especially when you're looking at a graph. Like, this ain't gonna work, boo-boo. We're not gonna have this. Let's go another one. Alright, so this one here, it says the cost C to rent a car for D days is shown in the table. Write an equation that represents this function. So I'm going to fill out this table just a little bit more because it's hard to determine, like, where does it start and all of that information there. So if we had day 1, let's add some days in here. If we had day 1, alright, and as I'm looking here, I'm like, well, how do they go, what's going to be the cost for a 1 day? It's hard to determine. But if you look down here, between day 5 and day 6, the difference is going to be, let's see, 285 minus 240. That's going to get me $45. Okay? So if I want to go for 1 day, it looks like the rental is going, I need to subtract $45. So if I subtract $45, that's going to give me my rental price for 1 day. So this is going to be $60. So I'll put up here $60. Okay? So they must add $45 for every day that you rent a car. So let's go to day 3. Day 3 would be here. This was day 1 right here. And day 3. So for day 3, I could add $45 to this 105. And I get $150. Okay. So I got to come up with an equation, okay? But if they're going to charge me $45 a day, why I still got the $60? So they must charge an initial fee as well. So let's take $45 away from that $60. If I take away $45, that's going to get me $15. So they must charge me $15. So I get charged $15 no matter what, plus $45 per day. And that's to rent the car. Okay? So they want C to be the cost. So I'm going to say C is equal to $15 that I have to pay plus $45 per day. And that's going to be your equation. This is real life. This is what y'all do. Y'all be renting them cars and stuff. This is what they do. And then they add us some taxes, but we ain't going to get into all of that. Let's go to another question. So it says, Mary and Kim go bike riding on some trails. Graphs of the functions representing one of their rides are shown, where X is the time in minutes and Y is the distance in miles. So it says, select all statements that are true based on the graphs shown. So the first statement says, Kim stops for 3 minutes. Well, let's look at Kim's graph. So, and I didn't make up this problem, just so happened to have my name in it. So anyway, if I look at Kim's graph right here, is she stopping for 3 minutes? Well, if you see this straight line from here, and I'm going to highlight it, from here to here, how many minutes is that? So that is 1, 2, 3 minutes. That's a true statement. When you see the flat line like that, that means that she is stopped. So that's a true statement. We'll check that. The next one says Mary stops for 2 minutes. Well, let's look at Mary's graph. Mary seems like she's keep going because she's climbing up from 0 to about 5. She is climbing, she's riding, and from 5 to 7 she keep riding, and then from 7 to 15 she keep going. So that's not a true statement. Mary never stops. So let's cross that out. The next one says Mary slows down after 8 minutes. So let's see, after 8 minutes is here. This is Mary, and after 8 minutes she's here. And if she's slowing down, she is, because she doesn't cover a lot of miles after 8 minutes. So if you look here, between 0 and, what is that, 5 minutes, she did about 3 miles according to the graph. And then from 5 minutes to 8 minutes, no, to 7 minutes, she did like an additional 1, 2, 3 miles again. But in this case, she slowed down because she did 1 mile after 8 minutes. So yes, did she slow down? She sure did. She was tired. Okay, let's do another one. It says Kim and Mary both ride the same distance at 15 minutes. So at 15 minutes, which is this last line right here, how long did they ride? Well, according to this, she went for 7 minutes. For 7 miles. And then for Kim, she went for 7 miles. So yes, that is a true statement. They went the same distance in 15 minutes. And then last one says, Mary and Kim both began the bike ride at the same speed between 0 and 4. Okay, so let's erase a little bit so I can see what's going on here. Okay, so 0 and 4 minutes. So 0 and 4. Now this is Mary, and she is here. So she went about, looks like in 4 minutes, she went about 2.5 miles. So she went 2.5 miles in 4 minutes. Okay? Now let's look at Kim. In 4 minutes, from 0 to 4 minutes, she went 3 miles. So she did 3 miles in 4 minutes. So here it says, Mary and Kim both began the bike ride at the same speed. No, Kim was going a little faster. So that's not a true statement. So we got our 3 statements that we can work with. All right, let's keep going. Oh, I think I'm done. Well, that was eventful. So that was another night of math. Thank you guys for tuning in to Mrs. Taylor's math class. As always, it's been a joy and a pleasure. I will see you again on next Monday night. So ta-ta for now. Bye-bye.